Good morning and welcome to the brief online demo as to the Wastix oil. I would like to introduce myself. My name is Henning. What we'd like to walk you through is the possibility of upgrading all types of residues, oily residues. I'm talking about the industries collecting heating oil residues, sludge, engine oils, used gearbox oils, used transmission oils, in order to upcycle these and give them a product status. We are here on a third-party operator's site, allowing to show real-time production of recycling products into marketable fuel oil grades. This line here is where it all started. It's the predecessor, the first generation of Wastix oil, and I'd like to show you a brief example of the type of quality of material which is being received as a disposal residue. So here you have a perfect example of what we are looking at. We're looking at a composition of heavy residue with liquefied product. The material is passed through a vacuum distillation unit, whereby the product is then upcycled, converted, and passed into a final product tank. In this case, it is a diesel being received. You can see diesel here, and the on-site installation allows for a small petrol pump, a small diesel pump. I will now take you through to the further development, the next line of generation of Wastix oil, which is larger in scale. We are talking here about a capacity of processing 2,500 liters of waste residue per day. The day working 3 shifts, so 24 hours. I'd like to show you the actual reception facility. The tank trucks, they would back up into the system here, and we would have the tanks discharging the input material, being the waste material, into this tank here. The product is being piped through a piping system being mounted here until it reaches the distillation unit. I'll give you an overview of the distillation unit being right here. Normally the distillation unit is being housed in a 20-foot container box. It's a modular system, so you could basically increase by duplicating, quadrupling the existing system. So what we have is, we have on the right hand side, we have the technology of pre-preparation of the waste material with process tanks, and on the left hand side we have the fully computerized control board. I will walk you through the actual process of the material, how it's being handled, how it's being fed through the technology. We shall start by having received the product. Now it needs some form of pre-treatment, pre-cleansing. This pre-cleansing is achieved in two stages. We have stage 1, where we, in this column here, we basically work with a 25 micron filtration system, which is then moved into a 10 micron filtration system. The product itself, to come into the filtration system, is being pumped from that last pump here. We move into the filtration system for that. Once having been filtered, the product goes into this buffer tank at the bottom. From the small buffer tank, the product now is pumped into the refining unit, and I shall walk you around to demonstrate the pump which actually moves the product. So what we have here is the actual pump pumping the treated input material into the distillation unit. The distillation unit is housed in this structure here, and we now move to the switch control mechanism, which is perfectly automated, being visible here. So we have an entire overview of what is actually happening, and maybe I will take this opportunity to walk you through what I've just started with. So what we have here is basically, on the left hand side, we've got the pre-treated waste, which is then pumped, as I just showed you, into the distillation unit. From the distillation unit, however, before reaching ambient temperature of approximately 250 degrees, the material is being circulated in a reactor unit, and it is circulated until actually the temperature is being given for the material to gasify, and from that moment on we split into, in this case, one fraction into two tanks. The technology is suitable of handling up to 4 different fractions, and of course, aside of the product fraction, we also obtain a waste fraction, which is at the bottom here and pumped into this waste residue tank. From these 4 product tanks, which I just wanted to mention, we have 2 product tanks which are, in this case here, we are upcycling heating oil residue, so we only obtain 1 fraction of product, hence the other collection systems are not in use. On the technology itself, it's very visible. You can see the actual loading states of the product tanks. I shall show you the product tanks as we go now. The waste container tank, the residue is here at the bottom to be also automatically being discharged and pumped into this waste disposal container. In the beginning, I did introduce the first generation Waste-X oil technology, whereby we had a look at the type of material being received as waste residue. Now, as you saw, there was a liquefied and a solid portion. This would be the liquefied waste residue, heating oil residue in this case, and that would be the obtained final product as diesel. Now, with the upgrade, you would achieve this type of quality, which after being discharged into these units is pumped via a piping system into these clean product tank. The entire unit is fully automated and no additional labor actually being required. Everything is being remotely controllable. To process the material in a 3-shift cycle, you would require 25 kilowatt to process 2,500 liters. The new generation being obtainable will be in a position to process up to 3,000 liters per hour. Talking the required energy, we are looking at a energy source here as being electric. In other words, this entire unit is currently being powered with electricity. Looking at the prevailing energy situation and the price for kilowatt hours going up, you may wish to consider substituting grid electricity with a generator set. The obtained fuel does meet generator specification, and in this case, via this switching unit, the operation at this entity is able to switch from electricity from the grid to actually the new Caterpillar installed fuel generator. This does offer some significant cost savings on the operational expenses. In other words, operating a unit as here, we are able to basically be self-sustained and totally independent from national power supply. I'd like to further cover one aspect of sustainability. Since we are actually processing waste residue material, we are obtaining a so-called end of waste status. This basically implies that we are able to certify CO2 emission reductions in comparison with originated fossil fuel material. This simply being the fact that waste generally has a CO2 neutral position, and we hence only calculate the various CO2 emissions arising from transport, processing through the unit and transporting to the client again. In the event of sludge, for instance, we are obtaining approximately 85% CO2 emission reduction when converted into ISO-spec material. That in itself, being certified by third parties, does allow for a further stream of revenue as CO2 emission reduction tickets in itself are marketable. In order to avoid any potential duplication, there is an opportunity to secure the originality via blockchain technology, simply issuing NFTs.